Scrap tire regulations vary from state to state, and to try to get all 50 states on the same page would be a big challenge. So what the scrap tire processor and contractors need to be familiar with what their state regulations are. And the way that we've handled that in several of my projects is we've written into the construction documents what the size of the piles can be, the stock piles can be. So that way, we're just copying that out of the state regulation. But that way, everybody knows, it's very clear, they don't have to go off and find a regulation that they're unfamiliar with.
As experts point out, use of TDA is well established in a range of civil engineering applications. With the documented success of past civil engineering projects, the establishment of ASTM standards addressing TDA sizing, specifications, and fill depths, and the widely recognized value of TDA as an effective substitute for other more traditional forms of aggregate, many say it's time to recognize this material as a legitimate reuse of scrap tires and as a desirable lightweight aggregate for civil engineering applications.
Is a demand for the knowledge about how to do this right. And as people understand how to do it right, then we're going to see more civil engineering applications. And already we're seeing, depending on the year, between 40 and 60 million tires a year are used in civil engineering applications. So this is a very significant market for scrap tires.
When considering TDA as an option in a civil engineering application, the project designers and stakeholders must consider the soil structure, existing Department of Transportation specifications, and existing ASTM standards to ensure its proper beneficial use. Now let's take a look at the various civil engineering applications for TDA, starting with lightweight road fill.
Regular road fill, if you take 1 cubic foot, so 1 foot by 1 foot by 1 foot, it weighs 125 pounds. If we take that same 1 cubic foot of tires, it weighs between 40 and 50 pounds. So if you're trying to take and build a fill over soft ground, you need to have something light. The types of ground conditions you'd have that would really dictate that you'd use a light material would be a soft clay material. You might encounter this next to a river, near the ocean. Also peat bog. And then once you need something that's light, now you're taking and trading off from one light material to another.
On the right-hand side over here, that dozer that's pushing the shreds out is taking the 15,000 yards of shreds that we had temporarily stored before the project started and dozing it into the roadway. They've been doing this for the last 3 days, and then the 8 dozer that's in the middle of the roadway has been pushing it down across the roadway, putting it between 3 and 8 feet deep, depending on the side slopes of the center of the roadway.
So all of this fill that we're seeing here in front of us, that's going to be covered with sand, and that'll be the level road?
Correct. We're going to end up putting a geotextile fabric over the top of this lightweight aggregate that's in here, and then putting 4 feet of sand, soil on there, putting a bituminous surfacing on top of that.
Yeah. What's the advantage of using this type of aggregate in road like this?
In this particular soft soils, that we have organic soils in here, if we used a heavy soil, it would settle and we'd continue to get cracking of the bituminous, and we'd end up having the peat underneath just fail on us. A lightweight material actually floats on top of it. It will actually bridge the roadway. We won't get any settling. We won't get any frost eating in the roadway.
Does it help the surface of the roadway? Does it last longer because of the flexibility of the material?
Yeah, basically our material is giving strength to the subgrade here. The soils there are so weak that if we didn't put this mat in the bottom, you'd end up having the granular soil start to move, which would break up the driving surface. So what we're doing is actually adding strength. Even though rubber looks like it would be rebounding, it's actually giving strength to the roadway.
We've been using shredded tires since 1992. It's got a number of benefits. Logistically, we can get a lot of material in a truckload, so we like that hauling aspect. And engineering-wise, probably most importantly, it's a tremendous benefit from both drainage aspects and what we call the shear strength of the material. And also it's cost-effective. We get a very good price on the material.
In the very first projects we were using the material, we were using it just for a separation layer between the weak organic soils and the granular surface material, just making a separation. And shortly after that, we started realizing that this material had lightweight properties. After that, we started realizing this material had very high drainage properties, where any moisture that would go into it would drain right to the bottom. And we started realizing that it also had insulating properties, where if you had sensitive underground structures, it would actually work as a thermal insulator to protect it. And as we've gone forward, we've even found uses for the void space in the rubber to contain moisture and to hold moisture. So it's just been a kind of an evolution of how this material can be reused in construction purposes, and what the engineer gets the benefit out of it. And in the middle of it all, we realized that this material doesn't have any ability to have capillary action. Moisture can't wick its way back up to the surface as in normal granular soil. So in the springtime, when frost heaving is a real issue, this material basically prevents frost from coming back to the surface.
California's done a lot of work with lightweight road fill as well. Does it help the roads in California?
Absolutely. It's from our perspective, it's a better solution for the repair. The factor of safeties are higher, less likelihood of failure in the future, and as well, you're doing a long-term fix, which isn't necessarily the case with the traditional approach. A lot of times, roads are repaired, and instead of using a TDA approach, they're using a traditional approach, and then they're repaired again 10 years later. And we really feel this actually is a long-term repair where you don't get that 10-year adjustment. It just is good for long-term.
I'm the director for the County Transportation Department in Mendocino County. We take care of the county road system. We had a storm damage site as a result of the 05-06 New Year's storm. We had probably 100 storm damage sites and 37 complicated sites. This was one of them.
How has the tire-derived aggregate worked out for that?
So far, it's performed really well. It's been through one winter and held up fine. The principle of lightweight fill is to keep a slide from moving by reducing the load, but using shredded tires for it was a new idea and a new concept.
So when we talk about landfill applications, there's a couple of different ways we can use tire-derived aggregate in landfills, and almost always what we're trying to use is a material that's got a high permeability. So we can use the tire-derived aggregate as a layer at the bottom of the landfill as part of their leachate collection and removal system. We can use it in trenches as we build the landfill up, and in those trenches we do one of two things. We take and use them to extract out the methane gas, and these days when the gas is extracted, generally it's taken and run through a power plant to produce electricity. Sometimes these trenches are also used to recirculate the leachate. And then it can be used as part of a leachate gas collection system that would be up near the top of the landfill.
For this application, which is landfill gas horizontal trench collection, we're replacing gravel with TDA. So the traditional design is to dig a trench and then put gravel in it and put a pipe in the gravel, and then put gravel back over the top, and then put trash over all of that, and then use it either to inject liquid back into the landfill by pushing water through the pipe, or to suck gas out by putting a vacuum on that pipe and then retrieving gas that's migrating up from the decomposition of the garbage. TDA will be laid down in the trench, then there will be a pipe laid on top of that, then there'll be more TDA laid on top of that, and then there'll be a piece of fabric laid on top of that to stop silt and dirt from coming down and filling in the void space, and then there will be refuse laid on top of that, and then eventually after a while they'll start using those trenches by putting in water and taking out gas. One aspect that makes it more efficient is that the TDA has a very high permeability value, higher than gravel, and so what that means is there's more void space in the TDA than there is in gravel. So not only is it replacing the natural resource, but it's also technically it's a little bit better at extracting. Is more void space for gas to come back.
This is basically a percolation area, so this is primarily for its permeability. It's beneficial also in that it's lightweight. This is going in the cover of a landfill, and they're using it to recirculate landfill leachate, which will go down through the landfill and actually help generate more landfill gas, which they burn here for electricity. So by not having a heavy gravel in the surface of it, it reduces some of the differential settlement that you would get in a cap. Landfills are going to naturally settle, but if they can settle uniformly, it reduces some of the long-term maintenance in the cap.
And some of it's going to be going around the methane pipes?
Yes, this system is a little unique. It's not only leachate collection system, but they are going to place a gas collection line in the top of it for the gas that comes up through the landfill. This landfill has horizontal and vertical gas wells. So these wells, these trenches that will be constructed, will have a leachate recirculation pipe and a gas circulation pipe.
You can see the wellheads. Those are part of the landfill gas collection system. And so there are mostly vertical wells that are drilled into the landfill, and then gas is literally sucked out of the landfill and routed to down there. And so what we have is a 5-engine energy plant that produces 15 megawatts of power, which is sold to our local utility district, the Sacramento Municipal Utility District. And so that provides green power to our local residents. We send a lot of tires out of here. Well, it's nice to bring them back and use them in the landfill. And so anywhere where we can find uses for these types of materials, I think it helps all of us, because then I'm not going out and buying raw materials that it costs energy and effort to bring here and utilize in the landfill.
We've been using scrap tires in a couple of different ways here at Tri-Community. One is as a component in the liner system of our landfill liner, our secure landfill liner. But we've also used them when installing our gas extraction wells in the landfill to help facilitate drawing gas out of the landfill. Tire chips are placed around the gas wells themselves, providing a highly permeable zone so that the gas is easily transmitted into the wells and then able to be extracted from the landfill. The primary reason we chose to use the tire chips is a financial one. We have the waste tires here. We're a waste management facility, and and so when we had the tires chipped, it's a material that we had readily available to us. The alternative would have been something along the lines of gravel or crushed stone, of which is, it's expensive. Obviously, the tire chips are very porous. When you pour the material in, very easy to pour into the wells, so that the material works very easily. It was easy for the contractor to use, and being highly porous, it's a very, very transmissive material. So, it's equally as functional as crushed stone, for example, but at significantly less cost.
I noticed that you're also using it for the landfill lining. How does use of the tire chips help the landfill lining?
Yeah, all of the cells, the secure cells we built here at Tri-Community, have incorporated using shredded tires in the liner system, and it's the last layer that we install, or in other words, the top layer of the liner system, and it really provides three things. It provides a protection from the liner, because the tire shreds would be difficult to penetrate, so that provides that layer of protection over the liner system. Again, the tires are highly permeable, highly hydraulic provide a high level of hydraulic conductivity, so it helps drainage to facilitate getting the leachate out of the landfill. And it also provides a freeze-thaw protective layer over the liner. Sometimes these liners sit over a period of time where they're not being filled, and with the winters we have here in northern Maine, the black tires help prevent freezing of the liner system and the components underneath. So it provides a number of different benefits for us, as well as being able to use tires again in some constructive way. We're faced with disposing of waste tires every year that we take in. Any way that we can somehow reuse those tires, even if they do end up in the landfill, at least they're serving some sort of purpose for us, rather than just being wasted.